And so now in this video for the Advanced Algebra Mock 2 review, I'm going over numbers 11 through 22. So continuing with solving the quadratics, now here, do we have a GCF? No. So we need to solve this one by doing bottoms up. So here we got x squared minus 5x minus 6 is now equal to 0. Now let's factor. What numbers multiply to get us -6 and add to get us -5? Well, first off, again, we're multiplying to get a negative, so both signs need to be different. So positive and negative. So really, we're going to end up subtracting the two. So the factors of 6 that would subtract to get us 5 are 6 and 1. But what needs to be negative to get us -5? 6. So here, -6 plus 1 is -5. However, are we done? No. So remember, right, we did bottoms up. So whatever we multiply by, now divide to simplify. You can't simplify, right? Bottoms up, 2x plus 1. Simplify, x minus 3. However, we are solving. This is equal to 0. So x is equal to +3. Use your fraction here. -1/2. Now in number 12, again, we're solving. Do we have a GCF? Yes. You divide everything by 5. So now I've got x squared minus 7x plus 10 is now equal to 0. Now we can factor. Numbers that multiply to get us 10 and add to get us -7. Now, this is a positive, so the signs are going to be the same, but we are adding to get a negative, so both signs are going to be negative. So factors that multiply to get 10 and add to get 7, 5 and 2. So in this case, -5 and -2, which means now when we solve, x is equal to +5 and +2, because what happens to this 5 here? It cancels out. 5 will never equal 0, so just 5 and 2. So now question 13, here we go. So again, no GCF, because I could divide 3 by 3 and 3 by 12, or 12 by 3, but we can't divide 5. So bottoms up, x squared plus 5x minus 36 is equal to 0. Now we factor. What multiplies to get us -36 and adds to get us 5? Again, we're multiplying to get a negative, so signs must be different. So we're really going to end up subtracting. So what factors would subtract and get us 5? 9 and 4. 9 minus 4 is 5. Now what needs to be positive to get us +5? 9. So 9 and -4. But again, whatever we multiply by in bottoms up, now divide to simplify. Simplify here, x plus 3, bottoms up, 3x minus 4 is equal to 0. And again, we are solving. So x is equal to -3, and use your fraction, +4/3. That's why the answer here is B. Now in question number 14, notice again here, we've got our parentheses, so we need to distribute. X squared plus 3x is equal to 40. But we can't factor yet, right? Because this must equal 0. So subtract 40 now from both sides. I've got x squared plus 3x minus 40. Now we can factor. So what numbers multiply? Get us -40 and add to get us 3. Again, we're multiplying to get a negative, so different signs, which means we're going to end up subtracting. What are the two factors that would subtract to get us 3? 10, not 10, I'm sorry, 8 and 5. Let me erase that. 8 and 5. For a minute there, I was going to say 10 and 4, but 10 minus 4 is 6, so that's not going to work. So 8 and 5. But what's going to add to or subtract to get us +3? That needs to be positive. 8. So 8 minus 5, +3. 8 times -5, -40. But again, we are solving. So x is equal to -8 and +5. Now question 15 and 16, our special cases. Notice how here we've got the parentheses, all being raised to the second power, but it's not by itself. We're adding 14 to it. So we need to first get that by itself and subtract 14 from both sides. So bringing down, x minus 3 squared is now equal to 16. Now we can't add 3 yet, right? Because it's inside the parentheses, all being grouped together. We need to get rid of the exponent. So we're going to take the square root. And x minus 3 is now equal to plus and minus 4. So now we've got two separate equations, right? We've got x minus 3 is equal to 4, and x minus 3 is equal to -4 here. So now when solving your two equations by adding 3, right, opposite operation, you end up with x is equal to 7 and -1. That's why the answer here is D. Now here, it is by itself. There's nothing outside. So we'll go through and take the square root. So canceling out your exponent, x plus 3 is now equal to plus and minus 6. Now we can set up our two equations. X plus 3 is equal to +6, and x plus 3 is equal to -6. So now when you go through and solve both equations, right, we're going to subtract 3 because that's what's being added. Subtracting 3, you end up with x is equal to 6 minus 3, which is 3. This will cancel out. Now be careful, right? Watch your signs. This is -6 minus 3, which is -9. That's why the answer here is A. Now looking at our graph, we're given this function that represents a ball being batted off of a tee. Now the graph is shown below. This is our function that was already graphed. So here we go. Now keep in mind, the ball is technically starting here, right? Because we can't really start in a negative. So the t is set up here, and this is the portion of the graph we are looking at. So we are looking at this portion. That's what represents the path of the batted ball. So how long was the ball in the air before it hit the ground? Now keep in mind, this is the ground, your x axis. So how long was the ball in the air? Boom, it hits the ground here after 2 seconds. How long did it take for the ball to reach its maximum height? So we need our vertex. This is the max. So how long did it take for it to reach its maximum height of 4.5 feet? 0.5 seconds. What was the starting height of the ball? So where did it start? Here at 4 feet. And what is the reasonable domain? So again, reasonable. Does it make sense that we're starting x values here at -1? No, because we can't travel in negative time. We're starting here at 0 and going all the way to 2. So now we're getting into our last questions, which are review with our stats. For this question, we're talking about electricity usage of dishwashers are normally distributed. It has a mean usage of 1.5. So we have a mean of 1.5. And we have a standard deviation, so here's our sigma, of 0.25. What percentage of the dishwashers is between 1.25, 1.75? Now look at the answer choices. What do you notice? This is the empirical rule where we end up having to use our curve here. So again, we have our mean at 1.5, and then now just using the standard deviation of 0.25. So we add 0.25. So 1.75 to 2.25. So now subtract the 0.25, your standard deviation. 1.25, 1, 0.75. So now notice, where's 1.25? Right here, 1 standard deviation below the mean. Where's 1.75? 1 standard deviation above the mean. So what is 1 standard deviation away from our mean? 68%. Our next question, so here we go. We have for this annual rainfall a mean of 150, so a mean of 150, and standard deviation, so here's our sigma of 36. We're looking for at least 190. So when I set up my curve, here we're at a mean of 150, standard deviation of 36. So adding 36, right, you get 186, then 216. Now I'm going to stop because notice, is 190 on our curve here? Does it follow empirical rule? No, it's somewhere between. So that means we will need to set up and identify our lower bound and upper bound. Same thing here for the next. See how 200 is not on the curve. So again, this will also be lower bound and upper bound as well. So we're going to have to estimate using the calculator when the values are not on the curve following empirical rule. So here we go. If it says at least 190, is 190 the lowest or the highest? The lowest. So then what did we put for the upper bound? Positive 1 million, right? Because we can't really put infinity, so we'll just use positive 1 million. Then let's see, so putting in our calculator, this is when we did second VARS. So second VARS. Then which option? Option 2, CDF. Now we put in our lower bound, 190, the upper bound, 1 million, then our mean, 150, standard deviation of 36. So this is the probability, 0.133. So 0.133. That is the probability of getting at least 190 inches of rain. So again, because this was not on the curve, right? We showed that before. We're going to use the same mean and standard deviation, but let's identify our lower and upper bound. Well, now notice this is between 100 and 200. So we are given our lower and upper bound. Lower bound, 100, upper bound, 200. So here we go. Again, second VARS, go to option 2. The lower bound is 100. The upper bound was 200. We already used same mean and standard deviation. And there's your probability, 0.835. So that's the probability of getting between 100 and 200 inches of rain. So now 21. 2 parts to this. A teacher wants to determine the percentage of students who participate in clubs activities in school. So part A, which of the following methods would have the most bias? So this is the least accurate. So like if you recall, the most bias, there were 2 options. There was the volunteer, your self-select, and then there's the convenient, where it's just convenient for the person who is conducting the survey. Then everything else is fairly more accurate, but these are always going to be your most biased. So if you have either of these 2, then you have your answer. And we do have that here. Which of these answer choices represents your volunteer or the convenience? A. Notice it says, the teacher interviews all the students in her math class. So which sample does this represent? What method? Convenience. Because it's just convenient for the teacher to just interview the students that are in her class. Versus, look here, the teacher interviews every 5th student who entered the school. you will get some accurate results here. Everybody has a chance. Randomly selects 400 students from a complete roster. Now everybody, that's your simple random. The teacher randomly selects 100 students from each grade level. There's your stratified. So here, which of the following methods now will have the most accurate result? So again, the most accurate is if you end up with the simple random, where everybody, you start with everyone, and everyone has an equal chance of being chosen. So if we're talking about at the school, we do have the simple random. Which of these answer choices is that? C. Because what is the key here that makes this simple random? The complete roster. So we're randomly selecting 400, but starting with our complete roster. So now everybody has that equal chance. Then 22. A study took a random sample of adults and monitored their bedtimes. The data showed that people drank coffee before bedtime were more likely to go to sleep. So that's the results. But what was the method to collect the data? Well, they took a random sample and just monitored them. All they did was monitor. They didn't ask. They didn't divide them into groups. They didn't ask every single person. So this is an observational study.